Hello everyone. Good afternoon or good morning, whatever you're joining from. My name is Dave Maria. I'm moderating Global Hebrew Virtual Meetups. Today, Anthony Nocentino will be talking about Linux fundamentals. If you have any questions, please write them and we will stop from time to time and the speaker will answer your questions. Please ask questions. Asking questions will make this session differ from listening to the recording. I think questions are really important for speaker to feel the audience. Otherwise, he will feel like he's talking to himself.
Which is like any other day of the week, right? So.
Right. This session is going to be recorded and I will put on our YouTube channel the recording. After the session will be over tomorrow, you'll get the link to the recording if you want to hear this again. And you can forward it to your friends who are not lucky to come over and hear. So, okay, that was my part. Anthony, we are ready.
Cool. Thank you. Do you see the slide deck? We good?
Yeah, yes, we're good.
Cool. All right, well, let's get started. So this is Linux OS Fundamentals for the SQL Admin, and I am Anthony Nocentino. So I'm a consultant and trainer and founder of Centino Systems, where I specialize in system architecture and performance, data platform MVP, Linux Foundation certified engineer, friend of Redgate, all that fun stuff. There's all my contact info. I'll have that again at the end of the deck. But seriously, if you have any questions, feel free to email me about Linux, PowerShell on Linux, SQL Server on Linux, SQL Server, Bash on Windows, all that fun stuff that's been coming out from the new Microsoft. I also have a Twitter handle where is kind of the main way for me to get information out to the community. So please follow me on Twitter, and a blog. So lots of material that I have in presentations also is on my blog. And I'm a Pluralsight author. So throughout this presentation, I'll kind of call out a couple places where I have deeper dive information on my Pluralsight courses. That this course specifically and a couple other ones I have on Pluralsight. And if you want access to those for free, I'm not trying to sell you anything. Just shoot me an email and I'll give you a 30-day trial code. And you can go and watch kind of deeper dive content. I only have an hour today, and I think I have like 40 or 50 hours of training available at Pluralsight, so for much deeper dive info. So today, in the next hour, I'm going to teach you all you need to know about Linux, the entire operating system from beginning to end. Nope, not really. What I did want to cover, though, is what I think is important for a Windows person having to start off using Linux for the first time. So I've got some big bucket points here, and we'll kind of go through the highlights of what we're going to cover today. And so first off, of course, we need to know the architecture, right? We want to learn how Linux is built. And then once we kind of know what or how it's built, we need to talk about interacting with it. How can we make the operating system do the things that we want to do? That's going to be interacting with your Linux system. And then we'll move into kind of the core of what's called the Unix philosophy, which is I/O redirection and pipelines. We're going to learn how to make command sequences using this special technique. Then we'll look at file system basics, where things live in the file system, and we'll move on into working with PowerShell in Linux. If you didn't know, PowerShell is now open source, and it's called PowerShell Core, and it's cross-platform, so you can run it on a Mac, Linux, Windows, whatever, and have the same exact environment to work in on either of those platforms. Then we'll look at how to work with packages, or in other words, how to install things on our system. And then once we have things installed, we need to certainly manage services, so basically starting and stopping or enabling and disabling services with systemd. Then we'll look at system resource management, so CPU, disk, memory, and where to look inside of our operating system for performance data, right? Because if we're DBAs, certainly that's going to be a critical function to us. And then finally, getting help. Like, where can you look in the operating system to find the help that you need to answer that problem that you might have? And Google is not a bullet point on that slide. So let's talk about the Linux architecture. And fundamentally, an operating system has one function, right? And that's to control access to the physical resources of the hardware, right? The underlying system that's supporting our work. And that's going to be in terms of CPU, memory, disk, and networking as well. Now, it's the function of the operating system to control access to that, right? So there's this thing called the kernel, and its responsibility is resource management and access. So the kernel is a special part of the operating system whose sole function is that, right? Resource management and access. And so when we do need to do work inside the operating system, we're going to ask the kernel to do that stuff for us, and then the kernel is going to go and arbitrate access to the underlying physical resources. And it presents those resources to us at these fundamental operating system abstractions, processes, pages, and the file system. So a process is really kind of an execution context to do work. Pages is the unit of allocation for memory, and also the file system, how I can interact with the disk subsystem of my hardware. So the kernel, that's for resource management and access, but we still need to be able to ask the operating system to do work, and we do that in the shell. And the shell is where we execute our commands. And so the shell will then start up our process and hand it off to the operating system to do that work. And so inside our programs, we really kind of have two things. We have what's called privileged state or user mode, non-privileged state or user mode, and privileged state kernel mode. And so it's up to the program when it needs to go and access a physical resource like a CPU or a processor page or some of the file system, it'll ask the kernel to do that via what's called the system call interface. So if I need to start up a new process, or if I need to allocate some memory or read from a file, the program that we're executing in user space will ask the kernel will go do that work for us and then hand us back that resource. At the top of the stack is us. We're the users, we interact with the shell, and of course as users we do one thing, we cause problems. And so that's kind of the stack, right? The user is going to interact with the shell, which is going to execute the program is going to interact with the kernel, and the kernel is going to go and interact with the hardware. And I threw two terms at you guys a little bit ago, kernel space and user space, and that's really kind of the major execution contexts inside of our Linux system, user space being the work that we're doing to support our program, calculating an average, sorting rows, things like that. Kernel space is where we're kind of supporting the work for that program, where we're going to be asking for creating new threads or reading memory or reading or writing to a file in kernel space. And so those are the two differentiations between that. Now, when we want to interact with our Linux system, there's really two fundamental ways we do that, text and graphically. And fundamentally, for DBAs or systems people, these servers are going to live in a data center, so we're going to be interacting with them over the network with what's called secure shell, right? Certainly, we could sit at the console of the server or the VM that we're working with, but really the fundamental way or the primary way that you're going to interact with a Linux system is what's called SSH or secure shell. What that means is I'm going to open a connection to the remote system, I'm going to log into it and be presented with a command line interface that I can go and execute commands against that system. Now, secure shell is going to be available to you in, honestly, it's starting to get, this list is getting bigger and bigger. I was just editing this slide before today's session. Of course, if you're using a Mac like I do, we're going to use the terminal app. But if you're on Windows, really your major choice was using PuTTY up until a couple of months ago, where that would be a client application that you can use to open a secure shell connection to a remote Linux system. Now we have Bash on Windows or Windows Services for Linux, and we also have a Win32 port of OpenSSH, which is being published by the PowerShell team. So the options are really starting to open up. I know when I do presentations on my Windows laptop, I've been using Windows Services for Linux or Bash on Windows to use SSH to connect to other servers or demonstrations. But of course, we also have a graphically, we can use what's called a desktop manager. So if I'm sitting at the console, I can start up what's called a desktop manager and get a graphical interface to the system. One of the big differences between Windows and Linux is in Linux I can have many different desktop managers, KDE, GNOME, there's a whole slew of desktop managers, basically whatever fits your preference for graphical. But again, if we're doing this as DBAs or servers, we're probably not even going to run a graphical console. We're going to leave it in a text-based console at the server. It could serve those resources for other things like doing the work that the server is supposed to be doing. Similar to RDP, we have a thing called VNC for remote graphical access to the console. Very infrequently used, I would say, in the data center, but certainly valuable in some contexts to execute or to remote login graphically to remote systems. So one of the big things that we kind of have to do right off the bat as systems people is be able to execute commands with privileged access, right? And so let's talk about access and privileged access. In Linux, security is based on user ID, which is a numerical identifier for each user. Of course, the operating system doesn't care what your username is. You're a number. And in Windows, you kind of have a security identifier, or a SID, which is that big, long, nasty alphanumeric string. On Linux, it's a simple numeric identifier. So you see here we have a special user called root, whose user ID is 0. The root is analogous to an administrator, or the administrator account on Windows, or SA in SQL Server, where this is the most privileged account. It can do anything in the operating system. And so we really want to avoid using root because we're people and we do things that might not be the one thing. Well, let's say this. The computer does exactly what we tell it to do. It might not be what we want it to do, though. And so we want to be careful and try to avoid using root. When you do log into a system as root, you can see you'll have a hashtag, which is what kids are calling it nowadays, or a pound sign at the command prompt. So there on the right, you see root is the username, at rel1, which is the host name, followed by a tilde, which is a shorthand notation for my current home directory, or my home directory, followed by the pound sign or the hashtag. That represents that we're logged into the system as root and we have privileged access. So you have a nice graphical identifier to indicate that to you. We also have regular named users, and I would encourage you to use a regular named user to log into the system, and you'll see that you have a $ at the end of your command prompt. Now, this is convention, right? The pound sign and the $. You can have anything there that you want, but by default, this is how it's configured in Bash. Now, that's how we differentiate between a privileged user and a non-privileged user. Now, let's talk about how we kind of switch between the two so we can do administrative tasks as DBAs or systems folks. And so we have this concept of being able to switch users or switch security contexts between users, and there's really two ways to do this. There's a command called su, which is short for switch user, and what su does, if I type su and I hit enter, what it will do is it'll transition me over to the root user, right? Because I didn't pass a parameter. I could type su and pass a parameter of any other username, and I can switch into that user's security context as well. So if I type su and then whatever other login, I would literally change to that login. What you need to know about su is that you need to know the destination user's password to switch to that user. You're switching your user context. And for root, that means you'd have to share the root password, or if you're doing work as another user or a service account, you'd have to know that user's password as well. And so it's really not good to exchange that information amongst other users because we don't want to be trading those passwords. So I'm going to talk in a second about how we can switch into a privileged mode without sharing those passwords. A second way that we can get privileged access to our system is with a command called sudo or sudo, which allows us to execute an individual command with escalated privileges. So we'll say sudo, and then the parameter will be the command that we want to execute with escalated privileges. We hit enter, and then it's going to ask us for our password, our very own password, so we don't have to exchange that information. And we'll then be allowed to execute that parameter, that command, with privileged access. So maybe we want to restart a service, and we can do that with that command combination. Now I can take sudo and combine it with su, so I type sudo space su, and then I can switch into the root user to do administrative tasks, but the value there is I use my password, not the root user's password. So it's an effective technique to switch over to do privileged commands, either sudo by itself with the command or sudo combined with su to switch to the root security context for whatever task you need to perform. Good thing is it's logged, so you'll know when this occurs when you use sudo, and it's also configurable. So out of the box, if you install Linux, usually they'll ask you, do you want this user to be an administrative user? You check that box, you hit OK, and it puts you in a special security group that allows you to execute any command with sudo. And that's kind of how you get to have what they would call administrative access. Now, we can be very granular with sudo, and there's a configuration file that says this user can execute this command with privileged access, a very granular way to control security there. So this is a quote from Brian Kernighan and Rob Pike, who are kind of the forefathers of the Unix operating system. The quote comes from the book, The Unix Programming Environment. And in there it says, many Unix programs do quite trivial things in isolation, but combined with other programs become more general and useful tools. And this is really kind of the core concept behind what's called the Unix philosophy, right? Keeping things simple and building more powerful commands using simple commands. It's a very, very fantastic book that I suggest you guys check out, The Unix Programming Environment. So we're going to learn in a little bit how everything in Linux is a file, and even how we interact with processes is actually represented with a file abstraction. So we're going to talk about how that works in the context of I/O redirection. So let's say we ask Linux to do something. We type a command at the command prompt, and it's doing some work for us. Well, there's special locations in memory inside of the process where we're going to read and write information at particular points in time to exchange data. And the very first one is what's called file descriptor 0 or standard in. That's the way we're going to get data into our process from external actors, like maybe the keyboard. So we'll be typing commands at the keyboard, and it's going to go into our process over file descriptor 0. Now, as our process generates data and wants to write to output, what it's going to do is it's going to write to another memory location called file descriptor 1 or standard out. And when it's doing its work, the default destination for standard out is the terminal, right? It's going to land on your screen and you're going to see what's going on. There's also another file descriptor called file descriptor 2, which is where we can write data when things go wrong, standard error. By default, that writes to the terminal. And so we can see that's how information is going to flow into and out of a process. Now, what's cool about with using these file descriptors is we could take those and do things with them, like redirect the I/O. So I can take that error output and I can redirect it to a file. So as my process is executing, normal output's still getting written to the terminal. But if something's going wrong, it's getting written to a file. So maybe I can go and debug or troubleshoot that later, right? So very valuable there. But it's not just restricted to standard error. I can do that for standard out. So that data, certainly you've done this before, we've executed a command, you've put the greater than sign, and then a file name. And this is how that information flows out of your process and into that file. We can also feed information into a process from file 2 via standard in. Again, a very valuable technique, but this isn't restricted to just files. Remember, this whole thing's kind of wrapped up in a file abstraction because everything in Linux is a file. So we can combine commands together and exchange data between commands. So let's say we have a directory listing on our screen, right? We're going to execute this program ls. So inside that process, we're going to have the 3 standard file descriptors. And let's say that directory listing is running off the screen, and there's another command that we can combine it with, more. And more is going to take 1 page's worth of output and then stop. And then you hit the space bar and you get the 2nd page worth of output on your screen and then stop. And so that directory listing that was running off the screen, we can build this command sequence where we take ls and pass it over a pipeline, which is that vertical bar there in the middle, and hand its output over to more. What will happen is ls will draw 1 line's worth of screen or 1 screen's worth of data and then stop. Then we hit the space bar and get more data. And the way that that works is ls is writing into file descriptor 1 or standard out. That information is flowing over into the standard input of the other process, more, on file descriptor 0, and then it's flowing out to our terminal. And so that pipeline is how text-based information or byte stream information flows through these programs, which are now grouped together in what's called a process group. And so this is really core to how we build more complicated command sequences. You kind of think when you first get started in the bash world on Linux, this is kind of some weird magical stuff going on under the hood, but really it's really, really simple when you kind of break down the components. Now, normally when I do the session in person, I wave my hands and I jump in front of the slide and say, don't look at the slide, because it's a reference slide. I want you guys to have all the syntactical goodness of being able to go do this on your own later, but I can't jump in front of the slide because, you know, this is virtual. And so we do have different syntactical ways of managing our I/O redirection for inputs and outputs to the program. So go ahead and check that out later on. So I let you in on the secret already that everything is a file in Linux. When I say everything is a file, I mean everything is represented as a file. So we just talked about how processes are represented as files, but their files are certainly represented as files. Directories are special files. Devices, your mouse, your printer, are represented as files. You know, things inside your system itself, the processor is represented as a file as well, and devices on your PCI bus. And it's all available in this kind of this unified file system hierarchy standard, which we're going to go through right now. So most commonly, your file system is going to be represented as a tree. And so on the right here, you can see we have kind of the major components of a basic Linux file system. At the top there, that kind of right angle slash is the / is called root. That's kind of the base of the tree or the root of the tree, right? And all things kind of emanate out from there. That very first directory, bin, is short for binary. So that's where our program files are going to live on our system. We also have what's called the variable directory, or var. Inside of there, you're going to have data that changes very frequently. So commonly, you'll see log files live in here. You'll see mail spools, print spools, and it's also the default location for SQL Server data if you're running SQL Server on Linux. MySQL as well puts its data into /var. There's a concept of a home directory, so each named user on a system can have a home directory. So here you see demo 1 and demo 2 have directories available to them in /home. And when you log into a system, you will land in your home directory by default. We have /usr, which is for locally installed programs. So often you'll see a link between bin back over to usr/bin on some distribution. So that bin directory at the top kind of collapses down into /usr bin. You'll see mount very often for remotely mounted file systems. So if you stick a USB stick into your system, that's where it's going to most conventionally be mounted. Remote file systems and shares also available conventionally in /mount. Another very important directory is /etc or etc. That's where you're going to find your system configuration implemented as text files. So we're going to go and manipulate things that have to do with the configuration of the operating system itself, all live in /etc. Now, this is all underneath the umbrella of what's called the File System Hierarchy Standard, or FHS. So most every Linux system is going to look very similar to this, whether it's Linux or Unix, regardless of distribution. So if you do kind of get into one operating system or one distribution, you should be able to figure your way around by knowing what the File System Hierarchy Standard is. I do suggest, if you want to go to sleep tonight, is if you go and Google File System Hierarchy Standard, there's a 60-page rigorous definition of what each and every directory is supposed to do. So if you are having some insomnia, that certainly would be a good cure. So I alluded to this at the beginning. There's a version of PowerShell available for Linux, or PowerShell Core. It's now in GA, so it is publicly available, non-beta, production-ready software. And they're releasing about every month. And so if you go to GitHub, you can go and participate in the development, literally, of a product that Microsoft ships with PowerShell and PowerShell Core and see what's really going on. I've done it. You can go and suggest feedback, and the team will evaluate it and implement it. Or if you want to, you can develop your own solution and submit it in GitHub and actually contribute to PowerShell as a product, which I think is pretty cool, especially a dramatic shift in how Microsoft is operating. The majority of commandlets are available to you. When we compare this to Windows PowerShell, the stuff that comes with the Windows operating system, not everything is available in PowerShell Core yet, but they're chipping away at that such that there is parity between the two versions, Windows PowerShell and PowerShell Core. If you want, you can have PowerShell on Linux be your default shell. You can literally, when you log into your system, instead of getting a bash terminal, which I'm going to show you how to do in a second, it'll just slide you right in the PowerShell. And that bit.ly link there shows you some steps on how to do that. So one of the reasons why I do bring up PowerShell in this session is it's a good way, because if you might have, it's a good way to kind of break the ice, I would say. If you're already familiar with the PowerShell environment, you can get those tasks done on Linux without having the overhead of starting up and having to learn bash. So it's a good way to get started. We also have remoting in PowerShell on Linux as well, which currently uses SSH as its transport layer. So I have lots of material on my blog about how to set that up. And also there's great documentation on the GitHub in the projects, under PowerShell projects website. WinRM is available, a WSMan and WinRM remoting does exist, but it requires that you disable Kerberos and turn on basic authentication. So I strongly encourage you not to do that on production systems in your environment. So let's get into a demo and look at how we can connect to a system via SSH. We're going to do some basic process management so we can learn how to use commands in our system, both PS, which is a command I'm going to show you for listing processes, and also get process. And then we're going to learn how to build those command pipelines together. So let's go ahead and switch over to the demo. And get logged into our system. So here I'm on a terminal on my Mac. So I've loaded up terminal.app, and I have a command prompt ready to go open. I have a VM running on this system that I'm going to SSH into, and that server is named server1. So we type the command SSH, and then the username and then the server name. So AEN is my username. I'm going to log into a server named server1, which is available on my system here. So now I'm at the terminal via SSH, and I see my username at server1 followed by a tilde, which is my current working directory. So if I do something like pwd, you can see that it's /home/AEN. That's where my home directory lives on the system. And of course, the $ there indicating that I'm a non-privileged user. So let's start off with some basic process management. And so the command that we type to get a list of the currently running processes on our system is PS. So here you can see I'm running bash and I'm running the program PS. And so if I want to get a bigger picture of what's going on in my environment, I can use the up arrow to bring that command back again, and I can type -AUX. And What AUX does is it's going to give me a list of all the processes available on my system. So I'm going to press enter, and you can see I have this big, huge list of output. And so let's go ahead and walk through how we can kind of wrestle this output into something that's a little bit more meaningful to us, right? Certainly we could scroll up in our environment and look at what we have at the very top there, but we're going to do something a little more advanced. So let's go ahead and type PS and feed it into that command more. Remember, more gives us one page of output at a time, and then it stops. And so as we build that command sequence, this standard output of PS, which normally would write to terminal, is now going to go across that pipeline into the standard input of more and give me one screen's worth of data. So now I can actually look and see what I have going on here. So from the top left there, we can see there's some column headers. So we have user ID, the username, followed by process ID, percent CPU, percent memory, virtual address space size, resident set size, and all the things that make up the process that is available in that row. On the very far right, we see the command. So the first process ID being the systemd command, which we'll talk a little bit about later. And then we have some kernel threads. The kernel threads are represented by what's in brackets there. So as we page down, we'll switch over and we'll start seeing regular user processes that are executing because they're no longer in brackets or square braces, excuse me. Now at the bottom here, we can see my commands. So you see AEN, the command more at the very bottom there. So now with that, let's go ahead and work through kind of a complicated command sequence to get the top 10 processes in terms of CPU out of this huge process listing. And really because I want to highlight how we can build a complicated command sequence. And so what I want to do first is introduce you guys to the command sort. So we're going to take that output from PS minus AUX, which lists all of our processes, and I want to feed that information into sort. What sort's going to do is exactly what I ask it to do. It's going to sort the data. It's going to sort the data with its default settings, which is going to be an ASCII sort on the first column of data. And so here we can see we get this great output of our column headers being at the bottom, because if we do an ASCII sort, capital U, it's going to come after roots, which are lowercase r. And so there we see it's at the bottom there. So we need to wrestle this command output to be a little more readable for us, right? And so I'm going to type a crazy command sequence, sort minus NRK3. Well, minus NRK3, where'd that come from, right? Well, over the years, I put that back into the muscle memory or the back of my brain. And what sort minus NRK3 does is it's going to sort numerically, right? That's the N, in a reverse order by key column 3, right? Now, this is intentionally going to be sounding complex. And so we're going to go ahead and sort that data. I'm going to pipe it into head. What head's going to do is give me the top 10 rows of data that come out of that command. So from left to right, we're generating our process list. We're sorting it numerically in reverse order by key column 3, and we're pulling off the top 10 rows of data from the output. So now you can see we're working towards getting the top 10 processes out here, but we still have something crazy going on. We have our column header data in the middle of our row output. Well, that's not really great from a process listing standpoint. So we have to go and make a modification to our command. We're going to go back to PS and do -no dash header. And now we have the top 10 processes sorted by CPU. Oh, one thing I do need to point out, key column 3, that's going to be column 1, column 2, column 3, CPU. That's where we get the 3 from. It's a lot, and I understand. This is intentional. Maybe not to scare you guys off a little bit, but I'm going to show you what your other option is. So I've installed PowerShell on Linux already. So I type pwsh, which is how we launch PowerShell on Linux. If you're used to PowerShell, this is a much simpler process, right? If I could type get process, I'm going to pipe that over into sort object. And I'm going to do that descending by CPU. Pipe that over into select output. Or select object. I was wondering why it wasn't tab completing. I'm going to pull off the first 10. First 10. Basically the same thing, right? But there's a huge difference if you're starting off and you have to figure out what PS minus AUX minus no header pipe sort NRK3 head. That's a lot, right? I get it. But you also have this PowerShell thing to help you get started and do the things that you're used to doing. And it manages all the output and things like that for you. And the concepts are the same, right? That output from get process flows into sort object and it flows into select object to give me the first 10, and then select object writes at the screen. So a good way to get started in the Linux world if you need to. Now, don't be too scared of the commands here, because once you start getting used to these, those small fundamental building blocks are how you can build these more complicated command sequences, because you're going to use each of these commands individually over time and get a feel for how they work. So don't be scared by using that, the native command syntax in Bash. All right, so let's switch over into making our system actually do what we need it to do, right? We need to be able to install software so that the server or whatever we were working with does the things that we want it to do. And the primary way that we install software on modern Linux systems is with what's called a package manager. And I'm going to focus this conversation on the Red Hat or CentOS type package manager, which is called RPM, so RPM package manager. And RPM is a package management system. Well, what's a package? Well, a package is a collection of programs, like the actual binaries, and the scripts to support that program, and then some metadata about what you're installing. So if I need to install a package, it's going to be the programs, the scripts to support it, and then the metadata, which is basically things like what's contained inside of the package, basically listing all the files, version information, and also some digital signature data to represent the actual fidelity of the package. Now that version information is very important, and also dependency information. So inside the package, if package A requires another package, that can be listed in our package metadata, which is great because that's how we can know how to install what we need to install to support what we need to install. So RPM, or the package management system, is really a suite of management tools that's used to install, upgrade, and remove packages. But what's interesting about RPM by itself is it doesn't provide dependency management. So if I type RPM -I package A, and package A requires package B, well, what RPM is going to do is say, your installation failed, go install package B, which kind of leads us with a problem, because that can be a long trail of things that we have to trace from a dependency standpoint. We'll talk about the solution to that in a second. Now, I'm focusing on CentOS and RHEL as the distribution of choice in this concept, and we're talking about RPM. In the Debian Ubuntu world, these same exact concepts exist in a thing called apt or dpackage to install packages. So go ahead and check that out if you want to kind of get these same exact concepts there. Now, that dependency management thing, that gets solved by a thing called Yum. Yum's also classified as a package manager, but really what it provides is a dependency management. So if I say Yum install package A, and Yum reads the package metadata out of the package A, and package A says, well, I need package B installed first, what Yum will do is it'll reach out to what's called a repository. It'll download package B, install package B, and then it'll install package A. And you didn't have to do anything. You just tried to install package A, and it resolved that dependency for you. So it's very nice in how we can install and manage our system. Now, that software, like where it magically pulled package B from, that software and the information about what's available for that software is available in what's called a repository. And there's a couple different types of repositories that I want to cover today. There's the mainline or base repositories available from the software publishers like Red Hat and CentOS. And those base repositories, this is where you're going to find the core operating system components to build your Linux system. So if I need to install Apache, which is a common web server on the Unix platform, that's going to come out of the base repository from my software publisher, most likely. Now, as you go along, you're probably going to need to add additional repositories to your system. And here are 3 common repositories that I wind up adding to my Linux systems: it's EPEL, RPM Forge, and of course Microsoft's now. Well, EPEL is the extra packages for enterprise Linux. The common story that I tell folks about why I would install EPEL, other than the fact that I just want HTOP, which is a tool I'm going to point out to you later, is a couple years back, the main base repository from Red Hat only had MySQL 5.1, I think it was. And I had a customer that needed MySQL 5.5 for a particular feature in their application that they needed to deploy. In that case, 5.5 was available at EPEL, 5.1 was available, or the newest version in the base repositories from Red Hat was 5.1, so we opted to install EPEL and bring down MySQL from there. Now, of course, from a third-party repository standpoint, if we need to install SQL Server on Linux or PowerShell on Linux, you're going to go and install Microsoft's repository. What's cool is you can actually build your own repositories for software distribution as well. So as you go along in your Linux journey, if you find that you started to build your own packages, This is a good way to distribute software. You can also mirror repositories locally within your data center. So perhaps you don't have internet access in your data center, so you can mirror a repository locally, point your servers in your data center at your local mirror, and get your installations and updates from there. Yum also provides system-wide updates. So I can type yum update, and it'll update all the software on my system. So very effective technique there. Again, apt provides all this functionality if you are using this in the Debian Ubuntu world. So let's jump over to a demo and look at some basic package management with Yum. So we're going to install SQL Server on Linux from Microsoft's Yum repository. And so let's go ahead and do that together. Switch screens here. Get a fresh console. So if you want to clear your console, you do Control-L. You'll get a fresh console to work with. So the very first thing I'm going to do is I'm going to copy and paste a command, because this is a long one, and we're going to walk through what this command does together. And it's going to be the first time we're going to see sudo, right? And so what's going on here is I'm going to execute this command curl with escalated privileges, because I need to stick the output of this file, or the output of this program, into a privileged location. And that privileged location is going to be etc yum.repos.d mssql-server.repo. When we're adding a repository or system, it's simply a file, remember, because everything in Linux is a file. So that repository information to configure Microsoft's production SQL Server repository is simply going to be a file in yum.repos.d, and we're going to go get that information from this URL here on Microsoft's website. So we're going to download that information, stick it in this file in this location with privileged access. And so let's go ahead and do that together. So I'm executing this command with escalated privileges. So right now it's asking me for my password. It's going to download that file and stick it in the right location. So let's go ahead and check out what that file looks like. Now, if you want to go into repos.d, you can see that there's a bunch of other repositories configured here. We can see the base repository is available here. We can see I have EPEL configured already, the MSSQL server repo that we configured here, as well as Microsoft's other production repository is available. So each one of these is a repository. Let's go ahead and look at the contents of the SQL Server one that we just downloaded. We can see that this is the configuration name. This is the repository name, and it's available at this URL. So this stuff's just coming over the web over HTTP. It's enabled, and it's got a GPG check. This is one of the key things about repositories that we need to be mindful of, is we're literally reaching out to the internet, downloading some software, and installing it on a server. So we need to make sure that that remote host is who it says it is, and that's where the GPG check comes in. So certainly you don't want to install random repositories on the internet on your local system without really trusting who that remote repository provider is. So with that, let's go ahead and type sudo yum install mssql-server. And this is how we install a package. So we're going to need escalated privileges, certainly with sudo. We type the command yum with the verb install followed by the package name. In this case, it's mssql-server. I'm going to put a -y on the end there, because when it downloads it, it's going to ask me at the very end, do you want to install this? Yes, no? Well, I wanted to answer that question for me without having to wait. So what's happening now is it's reaching out to the web, and it's going to download that package and install that on my system. So we can see that it's resolved the dependencies, and there were no dependencies for this package. So it simply went ahead and started bringing it, marked it for installation, and it got ready to go here. And now it's downloading that package, and it'll simply install it for us in the background. So while that's cooking, I'm going to jump back over to the presentation and move on, and we'll come back to that in a minute after we talk about managing services with systemd. So what's going on behind the scenes now is SQL Server is going to be installed. Then when we get back to that demo, we're going to need to be able to start up SQL Server and look at the various service statuses of SQL Server, and we do that with systemd. Now, systemd is kind of an overarching system management platform, I guess you could say. It does a lot more than just managing services. It controls the actual state of the system, logging, and things like that. We're going to zoom in mostly on service management today. And the way that we manage services on a Linux system is with a command called systemctl, or system control. So if you guys are familiar with using the command, let's like get service or set service on PowerShell, or even the services.msc management console, the same concepts really exist inside this command systemctl, because we can use that command to verify if our services are up and running or not. And we can also use it to start and stop and manipulate the, if they're enabled or disabled on boot with the systemctl. We'll walk through some of those examples in the upcoming demo. Now, like everything else on Linux, a systemd unit, or really the systemd unit is the abstraction that kind of represents the things that are managed by this systemd. And we're going to focus on service units today. And that service unit is implemented as a file, right? And so we're going to go in a second, we're going to look inside of what's called a unit file and see how those things are constructed in the event that we do need to make a modification to how a service functions. One of the major things that you wind up having to manipulate is dependencies, right? We can define a before or after dependency inside of our unit file, basically saying this service has to start before this other service or after another service. One of the common things that we'll use in systemd as systems administrators is looking at logs, right? Any service that's managed by systemd will take the output that is generated by a process managed by systemd and stick it into what's called the journal, right? So anything that hits the standard out from a process is going to be logged into a journal, and that journal is kind of a binary log format that we can query later on to pull data out. And so if there's something wrong with the service, this is the first place that I go to look to see what that output was from that command and go debug why that service is either stopping or not starting at all. And so let's jump back into the demo again and look at using systemctl to enable, disable, check the status of, and stop and start a service. All right, so SQL Server on Linux is finished. So let's go ahead and finish the installation as it's required here. So I'm just going to copy and paste that command. We can see that it completed the installation successfully. Let's go ahead and run that there. Of course, we'll agree to the license agreement. We're going to install Developer Edition today. So don't focus on the components of SQL Server. So I'm going to go a little fast through this, but we're going to focus on how to, my evaluation period has expired. That's going to make this demonstration a little more interesting. So let's go ahead and use systemctl to interact with SQL Server. So let's say, or the SQL Server service unit. So systemctl status. Actually, that's not what I want to do first. What I want to do first is we need to discover the unit name. So we just installed that package, right? And now we need to figure out how do we interact with that particular service unit. And so we need to discover what the service unit name is. And so we're going to do that with the command sudo systemctl. We're going to do list unit files. And what this is going to do is going to list all of the units that are available on this particular system. And you can see now, if I just kind of jump through this is a big list of stuff. And so we're going to use our newly learned abilities to search for a string in that output. So chances are the word SQL is going to be in SQL Server's service unit name. Just taking a bet there. And so I'm going to take all this output from all of the unit files or all the services or units that are managed by our systemd system, and I'm going to take the output, pipe it over, pipe into the input of grep. What grep does is it searches for strings. I'm using a -i here to indicate that this is going to ignore the case sensitivity of the string that it's going to match for. So this will match for lowercase SQL or capital SQL or any combination of that. And so if I look at the output now, I can see this is the service unit name that we wanted to find to interact with. So I'm going to copy that over. So you can see MSSQL-server, which is the service unit name, and then the type. Remember I told you there's multiple types of units in Linux. Well, this is a service unit. So now we know we can interact with that with systemctl status, say MSSQL-server. So here we can see the output of our status command for systemctl. Let's walk through this output together. So here you can see the service unit name and type again, a string that represents what it is or description, so the Microsoft SQL Server database engine. So we see that its status is loaded. And what that means is that systemd is managing this service unit. So anything that comes along needs to be registered into systemd for it to manage, and the installation process of SQL Server manage that for us. Now, we're kind of an interesting state. I wasn't expecting this to occur today, but this normally would say active OK, but now it says failed because I'm clearly outside of my trial period for this installation. So I have to figure out how to solve that issue. So that's where you'd find, is it actually up and running, would be listed under active here. We see docs, so there's a link to the very good documentation that's available at docs.microsoft.com. So we have our process ID. We can see exec start, which is the actual binary that SQL Server would load up as. That's going to live in opt MSSQL bin SQL Server. We have the return code, was killed abort. So it's certainly we're in a bad state right now. This is not where we want to be when we're talking about loading up our database engine. And so this, what you have right here is the last 10 lines, but there's only about 7 entries of our journal output. Remember I told you the standard output of a systemd managed process lands in the journal. Well, here's the output that we have from there. So we know we're in a bad state, right? So SQL Server entered a failed state. We have SQL Server database engine failed to start, and we know why, because I'm outside of my license period. One of the things I did want to show you guys is if you did want to stop a service, you do stop right here, but certainly it's already stopped. We'd throw a sudo in front of that to execute this command with privileged access, because certainly to stop a service, it's going to require privileged access. Start, change that verb to start, so systemctl start would go ahead and attempt to start the service, but again, we know we're in a bad state. Let's go ahead and look at another one. We do disable. And what that's going to do is prevent this service from starting when the system starts up. And I'm going to go back and look at my systemctl status output and show you where to differentiate between the two. So if we go and we look, we disable the service, it's still loaded, it's still managed by systemd, but way over here now, you'll see that it's disabled, right? That indicates that this won't start when the system reboots. And to fix that, or let's say set it up so that the system does start up, or SQL Server does start up on boot, is we change that to enable right there. And then we run this command again to check our status. And we can see that now it's enabled. So that's where you can look for to see if things are starting up or stopping on system restart. So lots of action right there in our system. All right, let's jump back over to the presentation. And talk about system resource management. So system resource management. So for DBAs, we care about performance. And let's talk about the big picture items for performance inside of Linux. So we have CPU, disk, memory, and network, right? And each of those could be a whole presentation on their own with how to work. We were talking about performance management inside of Linux, but we're going to talk about big picture stuff here. So when I'm looking at the CPU load on a system, on a Linux system, I'm going to look at a thing called load average and run queues, rather than just the raw CPU percentage. What load average is a calculation of basically how many processes or threads are in line to get access to a CPU. If I start seeing lots of queuing on a processor or for a collection of processors, then I know things are starting to really slow down, because if I'm in line to get access, or if I'm queued to get access to a CPU, then my program is not running, right? I'm not moving my program state forward, and certainly that'll show up as application delay. As DBAs, we care a lot about disk and disk latency. So of course, when we're looking at the performance attributes of our system, we certainly need to have ample space and latency, which is huge. We also have I/O waits, right? Which is when the process is dispatched in I/O and it's waiting for that return I/O. That I/O waits contribute to overall system latency as well. So we want to minimize those. Load average also takes into account not only the length of the run queues, but also how often I am in an I/O wait in part of my process lifecycle. Of course, we have memory. We care about memory pressure and swapping. In SQL Server on Linux, we care about this a lot. If you guys want to really dive into performance and performance information on SQL Server on Linux, I did a past marathon session in December where I talk literally about these topics for 75 minutes or 60 minutes and go through each one of these things, and I demonstrate what happens when SQL Server is under external memory pressure, or SQL Server on Linux is under external memory pressure on a Linux system, and what happens under the hood. So go ahead and check that out if you want to deep dive there. Of course, on the networking side, we care about throughput and latency, and of course, reliability. Did my data get to where it needs to go? And on Linux, we still have or SQL Server Linux, we still have all those SQL Server DMVs available to us that we'd get our normal SQL Server level performance data out of. So these are the big bucket items that we care about. Let's talk about where we get this information from in our Linux system. And so here's kind of a big list of commands, and in a second I'm going to take these commands, I'm going to correlate them back to the Windows commands or perf bond counters that you might be interested in. So top and htop are kind of the primary ways that I'm going to view the current state of my system. I like to call it it's like the task manager, the Windows task manager for Linux. So top and htop are the commands that you want to check out there. VMstat is going to give you a picture of your swapping on your system. Right? Am I swapping in, am I swapping out? So you get to know if you're having some memory pressure. Free is going to give you the overall picture of your available memory and total memory on your system. So free minus M will convert that from kilobytes to megabytes. DU minus CHS is going to give you the size of the directory passed in as a parameter. So if you need to understand how much disk space is being consumed by a directory, that'll give you that answer. DF minus H will give you the per volume data utilization or disk space utilization for particular volumes on your system. Now there's two final commands here. I use the first one, dstat, is kind of the point in time troubleshooting tool that I use. If something's going wrong right now, dstat's going to be my go-to, or I call it the monitoring Swiss Army knife, because it has such a wide array or collection of utilities that it can, or excuse me, performance attributes that it can monitor. But that's the right now, like I'm triaging a performance issue, I'm going to use dstat. If I need to answer what happened yesterday, then I'm going to use a utility called SAR, System Activity Reporter. What SAR will do is under the hood, it'll sample your performance data and store it such that you can go back and query from between time X and time Y for whatever performance attribute you think might be slow. CPU, disk, or memory, it's tracking all of that data for you. So a very effective tool to answer what happened when. So from a performance monitoring standpoint, let's go through kind of the major subsystem. We're going to look at the Windows perf bond counter that you might be used to using, and the Linux tool that you're going to use, and then the Linux attribute, the performance attribute that we're concerned about for that particular subsystem. So if we're looking at CPU, if you went to perfmon, you'd look at percent processor time. Well, in Linux, we're going to use top or htop to answer that question. And it's going to give us CPU usage in percentages, of course, and also load average, right, which is a very important value on a Linux system. For memory, we're going to look at Windows, you'd look at percent bytes or percent committed bytes in use. Well, on Linux, you'd use free minus M, and the output that you're going to get from free minus M is going to be the total amount of memory in your system, how much is used, how much is free or available, and also the size of what's called the file system cache. Now, if we're looking at disk from a space standpoint, of course, we look at percent free space in Windows. On Linux, we'd use df minus h, and we'd get things like total used available per each amount on our system. As DBAs, we care a lot about how fast our disk transactions are occurring, right, or IOs. So disk transfers per second on Windows, IOstat minus DX. And the output that you're going to get, you get a lot of output from IOstat minus DX. You're going to look at TPS, or transactions per second, reads per second, or writes per second. So you can get a feel for how fast data is flowing in and out of your system and what type read or write. Again, as DBAs, we care a lot about latency, right? So average disk transfers per second is what we'd look at in Windows. On a Linux, we'd look at IOstat minus DX, and there's two outputs that we want to focus on there, and that's going to be await and service time. Now, service time has 3 asterisks by it for a reason. So await is it measures the disk latency from the file system operation down. Like basically when I passed it off to the kernel and dispatched that IO out to disk, right? Service time measures from the device driver down, right, as that this transaction occurs. The kernel doesn't quite track NVMe data accurately with the whole concept of parallel queues that occurs inside of disk transactions. So if you read the man page for this particular, if you read the documentation for this particular command, it calls out that service time is probably going to go away. So you'll see that in a lot of documentation that says this is how you measure disk latency. Well, this particular attribute, service time, is going away. So look at awaits. Of course, again, as DBAs, we care about the size of our IOs. So average disk bytes per transfer is available in IOstat minus DX, and average request size. And so you'll just be able to see how big your IOs are as they're dispatched to your system. interface. So from a networking standpoint, we looked at the perfmon counter bytes per second, which is really kind of funny, bytes per second, because I don't know a network engineer on the planet that measures throughput in bytes. They use bits. Now, there's tons and tons of tools available for monitoring network performance on Linux systems. You have IFSTAT or Bandwidth Monitor NG or BWNG and nload. And we care about packets per second. That's how much data or how many packets are being transacted in a time interval, and then bits per second, how much data I'm moving. Of course, latency is also a key attribute there as well. I talked about DStat a little bit ago. DStat will pretty much record all of this data for you as well, but I did want to call out the tools that are available to use individually. Now, getting help. So inside of Linux, chances are you pretty much have all of the answers to your questions available to you on your system without having to go to Google, like I told you earlier. And the way you do that is with something called the man pages, right? And the man page is short for manual, is going to have for pretty much all the documentation that you're going to need. Even if you have an issue and you go and Google it, chances are it's just going to be the man page on the internet that's going to answer that question for you. So go ahead and start looking closely at how the man pages can provide help to you. If you do go down the PowerShell path, you still have Get Help. There is a little bit of, say, latency in the help for PowerShell core. You'll see a lot of Windows PowerShell pop up in the PowerShell Get Help commandlet. Now, there's also, this is when I teach this session to certification classes, I let people in this dark secret that is available to you on most Red Hat or CentOS-based systems. Is inside of a directory called USR Share Doc is going to be pretty much all the documentation that you're going to need about it for a particular package. And so that, again, in conjunction with the man pages plus USR Share Doc, you probably have the answer to the question you're going to need somewhere in these two different locations, because in USR Share Doc, you're going to find README files, help files, example configurations for various types of configurations, and also default configuration files for whatever package that you're working with. So for example, if you go and you look at MySQL or you look at Apache or HTTPD, which is the installation package, if you go into those directories, you'll see example and default configuration files for very common use cases. So all that stuff is available to you there. So some of the key takeaways for today, guys, is I do want to kind of make the point that it's just Linux is just an operating system, right? Once you get over the syntax and the environmental changes in the system, well, it is really not that fundamentally different than what you're used to, right? Because a lot of those concepts are the same. So some of the things we looked at today are architecture, right? And how Linux is built, I/O redirection and text-based pipelines, how to really wrangle that output and build more complicated command sequences. We talked about some file system basics. We looked at using PowerShell on Linux and how to build a very simple command sequence using the tools that you're probably already familiar with using. We looked at installing packages and then also interacting with those stuff that we installed with systemd and also some basic system resource management. Now, those courses that I kept alluding to that I have available on Pluralsight, there's 3 here. So understanding and using essential tools for Enterprise Linux 7, that's kind of the 101, where you do want to start for installation, command execution, permissions, and files. That all exists in there. For the deeper dive stuff, go ahead and check out Advanced Network System Administration. I'll go through performance monitoring, managing services, creating your own repositories is in there, and also how to interact with network shares. And then I was lucky enough to do a training video with Jeffrey Snover, who is the inventor of PowerShell, and Jason Helmick, who's a PowerShell MVP, to talk about open source PowerShell on Linux, which was a fantastic experience and also goes through why Microsoft open sourced PowerShell and what the motivations were behind that. So if you do have any more information, and if you also, with those Pluralsight things, free trials. So if you want to hit me up for a free trial, go ahead and shoot me an email. But if you have any questions, please feel free to reach out. You know, of course, we'll take questions right now, but after the fact, if you want to reach out and hit me up with a question, certainly would love that. So I guess, do we have any questions available?
No, there were questions about coding. I answered those, and no.
Oh, cool.
Anyone has any question? Good. Probably you answered all the questions that people might have.
Cool.
All right, thank you very much. I've really enjoyed this session. I wish I was at this session 2 years ago when I started learn Linux. I had to gather all that information from different places on the internet. I hope other people will benefit from it.
Well,
Thanks,
cool.
everyone. Have a
Thanks
good
for having me.
day. Have a good day and bye.
All right, thank you.